Properties of parallel lines. You are welcome to another interesting lesson. Now I want you to make an observation. From the diagram, we've already studied opposite angles. We've already studied angles on a straight line. Before I'll add another, I want you to check if you can identify the opposite angles and to check whether the values are equal as we said. So for me, I see this straight line here and this straight line here, and then this angle and this angle are opposite angle, and this one is 123.05 degrees. This one is the same, 123.05 degrees, which confirms that opposite angles are equal. There is another opposite angle here and here. These two are also opposite angles, so let's check them. So we have 56.95, another 56.95, which also confirms that opposite angles are equal. Now when we come to the diagram down here, this one and this one are opposites. Check the values and verify. This one and this one are also opposites. So you check the values again and then you do the verification. Okay, so this is a revision of what we already know. So when we are dealing with parallel lines, we already know the opposite angles there. We also have angles on a straight line. I hope you remember straight angles. So when you look at the straight line AB, there are two angles here. Now let's add them and see. 123.05. We are adding it to 56.95. So when we add these two angles on a straight line, we get 180 degrees. I hope you remember. That is not the only straight angle there. When you take line DG, you also see another straight angle there. You can do the addition, and then you take the other side of the same line DJ, you also have a straight angle. Then the downside of line AB also, whatever we have on the first, on the top circle or on the top diagram, we have a similar one on the down diagram. They share relative positions, so they are the same. Okay, now do we have another property that we know? I remember co-interior angles. Okay, so we have a parallel line here, a parallel line. These two lines are parallel, and then I remember we have a transversal line across them. So on one side of the transversal line, now when we take the right side of the transversal line, we see that an angle has been formed between the transversal line and then the line HI. And then another angle has also been formed between the transversal line and the line AB. So now let's add their angles to see whether we can confirm co-interior angles in this. So we have, it gives us the same values. So we have 123.05 that we have worked on, the same values that we worked on. 123.05 plus 56.9. So this is 56.95. This is 123.05. And so the addition, we've already done it. Okay, so it becomes true. Now the other side is also true because the values are also the same. Okay, so we've seen opposite angles, we've seen angles on a straight line, we've also seen co-interior angles. Now which ones are we going to add? I want you to take a look at relative positions. Now when I say relative positions, I'm saying that when I manage to lift this circle and then place it congruently on the second one here, what will happen is this angle here will fall congruently on this angle. I hope you can see that. Okay, then we have others. The down angle here will also fall congruently on this one. Can you see? Good. This one will fall congruently on this one. What they do is they have the same relative positions. That is, if the angle on this one were to be drawn on this is where it will be. That is what we mean by relative positions. Now these pair of angles which share relative positions are called corresponding angles. Corresponding angles. Then we also have alternate angles. So when we look at this side, this angle here alternates with this angle here, and the angles are supposed to be the same. So when we check, we can see that 56.95 is the same as 56.95 here. So these are alternate angles. Another set of alternate angles is this. So this is also a set of alternate angles. Okay, so you take notes. Now let's change the position of the diagram to see whether our properties will be maintained or whether the values were like that because they were fixed. So now look at them. This now becomes 72.7, and then we see it alternates. Okay, you should be pausing the video to check the values. I see they remain equal, so 115.32, and then when I look at the opposite, 57.12, and then the other side too. So this is true that properties of parallel line remain the same irrespective of how the transversal line is drawn. Okay, now I've used the same color to indicate corresponding angles, and so when you look at this angle and this angle which share relative positions, we see the values to be equal. So we have 54.05 degrees and then 54.05 degrees on both angles. Then we look at the others, this one and this one. They also have the same values, and I've used the same color to indicate corresponding angles. So look at it, check for each one of them and study it. Then we also have alternate angles. So this one alternates with this. So alternate angles have also been indicated with the same color. So when you look at this value and then this one's value, you see that we have the same value, 54.05, 54.05. And then when you come to this side, the one also indicated with that background, we also see their values to be 125.95, 125.95, and so these are alternate angles. Let's take note of them. We have opposite angles. So with opposite angles, I've also used blue and then red backgrounds to indicate them. So the blue backgrounds are opposite each other, as we have this opposite this. We also have straight angles. So angles on a straight line, you can add them to C. We have this, this, we have this. It doesn't mean those I didn't indicate. When you take this one to it forms angle on a straight line. And then when you take this one too, I hope you can see. Yes, I didn't want to make the work dirty. That is why I used this for one side and then another side like this. Okay. We also have co-interior angles. I believe you've seen. I've even been too quick to mention. I should have given you the opportunity to look at it, to identify it without me saying it. So you just confirm whether the co-interior angles indeed sum up to 180 degrees. Alright, so thank you very much. I want to draw your attention to the fact that parallel lines are not two lines. If you have a line here, lines that are parallel to this line are infinitely many. And so in a situation where you have a question like this, so this line is parallel to this line. You have a question like this and the question requires that you find the value of the angle x, where you've been given this angle to be, let's say, 50 degrees, and then this angle to be 35 degrees. Let me quickly name my line, my points. Now, what you have to note is that you have the liberty of drawing an imaginary line. So we are going to draw an imaginary line through the point J. That line should be parallel to the two parallel lines that we already have. So that will give us this. Now, after drawing this parallel line, you see that, let me call the line K. You see that line AB being parallel to line K has JB as a transversal line. So JB becomes a transversal line between the line K and the line AC. With that, let's identify our alternate angles here, this and this. And so we have this angle to be 50 degrees. Remember, alternate angles are equal. In a similar vein, you see the line JE also serving as a transversal between the line DF and the line K, which is this as a transversal. And so we find another alternate angles here and here. So this one will also be 35 degrees. Now you put them together, 35 plus 50 degrees, your angle is going to be 85 degrees. And so with this, our angle X is equal to 85 degrees. This is just to draw our attention to the fact that parallel lines are innumerable.